Today we're going to talk about how to install the EZ2208 on the Octopus Max EZ version 1.0. So there's a couple things I need to talk to you about first before we do this. Obviously you're going to need a couple of things, first of which is going to be your stepper. Then of course we're going to have to adjust the actual current that comes in, and we're also going to use a cooling fan when the stepper goes on. So I'm going to show you how to do those. So first things first, let's go over to the actual manual and see what it looks like here. So we have the Octopus Max EZ manual. What I'm going to do is I'm going to do a search on the stepper. So I'm going to probably do EZ. So let's see what we got here. So we have EZ there. Now we have the actual steppers right here. So I'm just going to click on that. Now as you can see, the stepper that we're going to be using is actually UART, which is Universal Asynchronous Receive and Transmit. That's what this means for the actual name of the stepper. Now, as you can see down here, if we were to do sensorless homing, which we can't do with the TMC2208 or EZ2208, because it does not have that functionality. So we're just going to plug it in. So I'll show you how to do that in a moment. And then over here we have the driver voltage. Now, as you can see over here, the voltage for the driver either has high voltage or we can do a lower voltage. Now, if we use high voltage, we have to use a different power supply. So I'm only showing you on 24 volts for this. Now, the fan down here for actual cooling has 3 different settings. So you can see that there's 5 volts, 12 volts, and 24. But because we're using a 24 volt power supply, I want to keep this simple and just use the 24 volts that would be for the actual fan over here. So let's go back over to the board and set this up. So on the board, we're going to grab the actual stepper, which is the EZ2208. We got to note the notch position, so it's going to face us. We'll place it down in here, but before we do that, I actually want to place the jumpers in place. So this is going to control the voltage for the actual stepper. So it's going to be right here for these 2 top pins because we're using 24 volts. And then of course we want to do the fan voltage, and the 24 volts is at the bottom right here. So as you can see, I'm using the second fan because the first one usually is reserved. So I'll use the second and show you how to set that up in a second. So let's connect the fan real quick here. So we'll place this inside here. Next we'll do the actual stepper. So we'll rotate it and then we'll place it in here. So make sure that's seated correctly and you should be fine. Now let's connect the actual stepper motor for the NEMA 17 stepper that we're using. So this is going to be the X-axis that we're working with. So we're also going to need an end stop. So I'm going to have to use this one here that has 2 wires. So we have ground and we have signal. So the red's going to be signal and the black will maintain as ground. So to check where that is, what we'll do is we'll go back over to the desktop and we'll actually look at the pin out diagram. So let me bring this up for you so you can see what I'm talking about. On the desktop, we're going to go to hardware and we have the pin out diagram. So I'm going to double click on that. And up in here, you can see that the min1, that corresponds to the actual steppers for the X-axis. So you can see that it's ground, voltage, and then we have signal. So we're going to be on these 2 pins for ground and PF0, which is our signal pin. And I'll show you in a little bit more depth in a moment why that makes sense. So let's go back over here and connect this real quick. So it's these two pins right here, and then the one to the right is voltage, which we're leaving empty at the moment. So let's go back over to the desktop and actually go to Marlin after we go to our desktop and do one other thing. I need to actually show you in here in our downloads folder the actual Marlin firmware that I actually pulled down. So down here I pulled Marlin, and what I did is I right clicked and I did extract all. So before we do anything else, what I want to do is show you the website. So over in here we have the Marlin firmware website. We're only going to be pulling the download here. All these others are for different things, like here it says AVR and ARM. That means that it's an 8-bit processor versus an ARM processor. So you can do like a RAMPS for AVR, and then we're working with a 32-bit processor. So let me go over to the desktop and show you what I'm talking about. So the processor in this case is right here, and on it is written STM32F something. So let's see if we can zoom in real quick. So as you can see right here, we have the actual stepper, and it says STM32H, and I believe that's 723. So it may have been slightly rubbed off, but let me zoom out real quick. And the other thing that we need to do is actually pop out the SD card, which is right here, so we can program it. So I'm going to connect it inside here, and then place this in my computer's USB drive. So you might hear a beep in a second. Hang on a second. There we go. So let's go back over to the actual computer for a second. And I already have the actual extracted firmware in my downloads folder, which is over here. So what you can see is this. So we're going to go back over to VS Code. We're going to click over here to the Explorer, open folder. Then we're going to go to our downloads folder, Marlin 2.1.2.1, and we're already in one, so we're going to go into the second one and then select folder. That'll bring up your environment correctly. So now what we need to do first is find our actual configuration. So we're going to go to the Marlin folder, the source folder, the core folder, then boards.h. Inside here, we're going to search on Octopus. And as you can see, there are other ones up here, but the one that we're looking for is down here. So we're going to click here, right click, we're going to copy, and as you can see, there's two different versions of the actual MCU that I pointed out earlier for the STM32H723. So there's a VE version and a ZE version. So let's go back over to the desktop for a second and I'll show you what I'm talking about. So if I zoom in, you can see this has a ZE version. So let's go back to the desktop, and what we'll do is we'll actually copy this again, even though I copied it a second ago, minimize core source, go to configuration H and search on motherboard. Inside here, I'm going to paste over where it says the ramps, and we have our stepper now. Now we need to change the serial port to -1. And the other thing that we need to do is change our stepper. So we're going to search on A4988, and that'll bring us to the right place. Then we're going to find our TMC2208, which is our EZ. So we'll copy that and we'll place it in the X position. Now, when I was talking earlier about the actual end stop, I want to show you this real quick. If you go to Source, Pins, then find our processor, which is STM32H7, you'll see that we have our EZ right here. And these are the pins that equate to the board. So you can see that PF0 is the actual X diag pin. This is used for your end stop, so M1. So that equates to what we were looking at earlier over here. So you can see PF0 is our signal pin. So I'm going to close out of that. I'm going to close out of this as well. But now we need to do advanced configurations. So we're going to search on 800. Let me do this again here because I did it in the wrong spot. So let me click here, Control F, 800. I'm going to search a couple of times to find our stepper, which is right here. Now, obviously, we're using this one. Now, I need to point out that the microsteps is based on something over here. So I'm going to have to search on 80, 80, and that'll bring us to default access steps per unit. Now, this is the one that we're working with, being 80. If we wanted to increase the microsteps, say we want to take the 16 and double it to 32, we have to proportionally increase this to 160. If we want to increase this to 320, then we have to do the same over here by doubling this yet again to 64. And so on and so forth, all the way up to 256th of a step. So now that we've got that done, we actually do want to turn on some debugging initially to check what's going on. So I'm going to search on debug underscore TMC. I probably have this backwards, so it's TMC underscore debug. And that'll bring us to the first thing. We want to monitor the status, so we'll hit Control / to uncomment, and then we'll find the second one down here, and we'll uncomment this. Now you can re-comment these again after you're done configuring your steppers. The other thing that I want to show you is how to set up the controller fans. So we're going to search on Control F, and we're going to say use underscore controller, and that'll bring us to controller fans. So we're going to have to hit the Control / to remove the comment, and this will allow us to actually manipulate this down here. Now we have a controller pin that we have to use. So in this case, -1 means nothing at the moment. So I'm going to hit Control / to remove the comment, and we're going to have to use a custom controller fan pin. So that means if we go over here and we look at the actual pins that are up here, so we're in the slot over here with the next two pins for fan 1, you can see that the actual pins, in this case, I believe it's PA5 for the pin that we're looking for. Now I might be incorrect, but they have two signal pins here, so I'm kind of confused. So let's see if we can drill down to this a little bit more. Yeah, I think it's PA5. So I'm going to minimize this, and I'm going to say that it's PA5. So PA5. And the way we can confirm this is we can actually take this part, copy it, go back over to the pins for this, and then search on that and see what it says. And so it does say fan 1, so that's the actual pin that we're working with. The reason I'm showing you this is so that you can actually understand how it relates to the pinout diagram, and also how to configure your fan, of course. So now that we have that configured, let's go back over to the advanced config, and I'm going to search on 24 volts just to show you this. We're not actually going to use it normally. So right here, if you use spread cycle with chopper, you're going to have to set your default chopper voltage for your power supply. We're just going to be using the functionality for quiet stepping. So I'm going to paste this here just in case we want to use it in the future. So that is something different for the functionality. Let's see if we can do a quick search here on, let's see, TMC 2208. And we'll see if it's a data sheet so we can see what we're working with here. So there's a data sheet for it that you can pull up here. And inside here it talks about the functionality. You can do step-dir, but I wouldn't suggest it with the stepper only because the greater functionality is actually stealth chop, which makes the printer more silent and also controls the coolness of the stepper. So you can look up the description. This is a rather long manual, but at least you can see the outline of the features and benefits to it right here. So we're not going to worry about that too much because you just want to see how to configure. So we're going to go back over to VS Code. And what we're going to do is we have to set the environment to actually build. So I have to go to platformio.ini. And as you can see, the default ENVs or environment is set to Mega 2560. So we need to fix that because that's not our chipset. So I'm going to minimize some of this real quick here so that we can actually see what's going on. So up in here we have the INI folder. So we need to find our chipset, which is the STM32H7. So we'll search on Octopus here. And inside here, we have to find the one for our particular one. Because you remember there was an actual ZE version that we were using, which I believe is this one, but we can verify against our board real quick. So if I zoom in, you can see that there's a ZET. So I'll zoom out real quick and I'll go back over to the actual desktop and I'll copy this. So that appears to be the correct one. So I'll minimize this, go back to the platformio.ini, highlight the Mega 2560, and paste this in here. So let's do an actual clean with the garbage can down here. And next what we'll do is we'll actually do a build with the checkbox down here. Now if you don't see the checkbox, that probably means that your actual plugin is missing up here. So let's see what it is. It's actually extensions, pardon me. So if you click here and you type platform.io, it's the very first one on the list that you need to install if it's not already installed. So I'm going to skip it for now because it's installed here. So we're going to build. Now the build process, if something occurs where you see yellow, it just means a warning. You can normally ignore that, but if you see red during the build, that means that you actually have something you need to fix. So we're going to see how this works out. Hopefully it's going to be okay, but sometimes it may tell you to fix something in your configuration. So let's see what we got here. If we want to watch the build, we can go to platform.io, build, and we can actually see it start to populate in here. Now we're waiting on firmware.bin. If we see a .elf, that's just before we get bin. And the elf, I believe, is for troubleshooting, but I have yet to learn how to use it. So that might be a future tutorial. So here's the elf and there's the bin. So we'll right click on this and we'll say reveal in File Explorer. Inside here we want to copy it to our D drive. As you can see, I have my firmware.cur here. If you have trouble loading firmware, you can put a blank one here first, and then also you're going to need this. So I'm going to send this to the D drive. So let's confirm it's there. And this is how I keep track of old firmware. So if I wanted to reload it, I'd rename it to firmware.bin. this is a way for me to just back it up. So I'm going to pop this out and go over to the desktop. I'm going to place this in the drive over here. And I'm going to power the board that's currently not powered. Now, as you can see, I have power for the board running to my power supply, and then I also have motor power. So let's plug this in and see what happens. Hopefully there's no smoke. So you may hear a ding on the computer. If not, it's okay. It looks like on my computer right now it might be muted. And that reason might be because this is not connected. So let's connect it right here. And then let's see what happens on the computer. So let's go over to Pronterface and see what we've got. So I've got Pronterface up and I've got the actual board so you can see it. What I want to do is I want to first connect to it. So it says COM port 23, but we're not sure if that's correct, but I have my device manager up and you can see that it says COM port 23. If I were to disconnect the Ethernet, this would disappear if something were incorrect. So let's try COM port 23 and see what happens. Over in here it says the printer is now online. So I'm going to put it on the main screen for you for a second, and I'm going to do a M122. This will allow us to check the status of the actual steppers. So in this case, the one stepper that we have is okay. So the next thing I want to do is actually check to see if my end stops are okay. I only have one connected, so we'll do M119 and press enter. And you can see that it's open for the one that's connected. The other two are unconnected, so they say triggered. So let's test the end stop real quick here. So I'm going to click it with my hand, and then I'm going to have to test it by doing the command again. So let me bring up the actual desktop. I'm going to press enter, and then I'm going to go back over to the desktop so you can see what I'm doing with my finger. And as you can see, it does say that it was triggered. So I'm going to release my finger. I'm then going to go back over and test it again on the desktop. So we'll do the command again, and it's functional. So now what we can do is we can actually try and move the stepper to home. But in order to do this, I actually have to trigger it with my finger. So let me bring that up again. I'm going to trigger this when it gets close to the edge on home. So let's see what happens. Okay, so I may have to double click it when testing it with my finger. We'll see what happens. But as you can see, the fan did go on. Now, if you want to shut the fan off, it takes 60 seconds based on what's in the actual information for the actual firmware, which I'll show you real quick. If we go over to the desktop, go to the firmware, if I were to go into here for advanced and I search on, hang on a second here, controller fan, let's see what we got here. It's probably use controller fan. And let me take this out. Apparently my search results are not working because I'm searching on configuration.h instead of advanced. So we know it's not in there. So let's do this again. Controller underscore fan. And down here you can see that if we were to go idle for more than 60 seconds, it would actually disable the fan. So if you want to experiment on your own, you can change that to 5 seconds and then go into Pronterface and you can say motors off, and after 60 seconds the actual fan will go off. But at this point I want to thank all my patrons and people on PayPal, and now on Buy Me a Cup of Coffee as well, which I'll put in the description if you don't want or wish to join Patreon. But I will play at the very end of the tutorial a thanks to all the patrons and people on PayPal at the moment until I start seeing people on Buy Me a Cup of Coffee. So everyone, take care, be safe, and I'll talk to you later.